Namaste and welcome to the tutorial of linear mappings and matrices. In this tutorial we will discuss problems on matrix representation of a linear operator. For that I have considered a problem statement from a book Linear Algebra, 4th edition, Shom series outline. The problem statement is: let there be a mapping F which maps two-dimensional real space into another two-dimensional real space, be a linear operator defined by f of xy. This is given by 2x plus 3y, 4x minus 5y. Here we have to find the matrix representation of mapping F relative to the basis S, which is given by this, and the matrix representation of mapping F relative to the basis E, which is given as in like this. So now let's start with the section A, in which we have to find the matrix representation of F relative to the basis S. This can be done in two steps. In first step we will find out f of u1 and then we will write it as a linear combination of basis vectors u1 and u2 like this. And by using our mapping function f of xy, we can even evaluate the f of u1, and the value of f of u1 we can substitute in equation 1.1 to get two set of equations, and by solving these two set of equations we will get the values for a11 and a12 as in 52 and minus 22 respectively, and hence we can represent f of u1 as a linear combination of u1 and u2 by substituting these values in equation 1 again. Similarly, in step 2 we can find out f of u2 and we can represent it as a linear combination of u1 and u2. For that, we will represent first f of u2 as a linear combination of u1 and u2 with the help of the unknown variables a21 and a22, and then by applying the map f of x, y on the f of u2, we will get the values that we can substitute in equation 1.2 to get two set of equations, by solving which we will get the values for a21 and a22 respectively as in 129 and minus 55. This we can substitute in equation 1.2 again to represent f of u2 as in linear combination of basis vectors u1 and u2. Now by considering these two equations, or the linear combinations of basis vectors u1 and u2, that is f of u1 and f of u2, we can now represent our mapping F relative to the basis S in the matrix form by writing the coordinates of f of u1 and f of u2 as in column. The second part of this problem statement you can solve by yourself. You can try it by yourself by using the same steps. Thank you.